We are discussing the IIT-JAM 2012 Modern Physics MCQ. In 2012, the pattern of IIT-JAM was there were 15 questions of 6 marks, 15 questions MCQ of 6 marks, and 10 subjectives of 21 marks. Total marks was 300. This pattern was changed in 2013 and 2014, and whatever the as of now you paper pattern you was checking out, that was implemented in 2015, and from 2015 the pattern remains same, that is 10 marks, 10 into 1 marks MCQ, 20 into 2 marks MCQ, and then 10 into 2 marks MSQ, 10 into 1 marks net, and 10 into 2 marks net. So this pattern was prior to 2000 from 2005 to 2012. So let us discuss it. When the temperature of a black body is double the maximum value of its spectral energy density with respect to that of initial temperature would become. Solution. The energy density U relation with temperature is given by U is equals to A T की power 4. A is divided as 4 by C sigma. Further, this relation you can note it down. For black body, power is equals to sigma by T की power 4 is equals to C by 4 into energy density U. That is energy density. So that is the relation which you have always kept in mind with respect to black body radiations. Now, when T temperature is T naught, energy density is U naught would be A 2 to the power T naught to the power 4. Temperature becomes 2 T naught, energy density becomes U is equals to A 2 to 0 power 4, that is 16 A T 0 की power 4, which is equals to 16 times of initial energy density. Thus, our option C is correct. Light takes 4 hours to cover the distance from Sun to Neptune. If you travel in a spaceship at a speed 0.99 c, where c is the speed of light in vacuum, the time in minutes required to cover the same distance with clock on the spaceship will be approximately. So we have to determine the time period covered, time required to cover the same distance observed by an observer in that spaceship. So, solution. The proper distance between Sun and Neptune is, that is D0 would be 4 into 60 into 60C, which will be 240 into 60 into 3 into 10 to the power 8 meter into seconds. So that would be the proper distance. Further, the observer in the spaceship observe the contracted distance that is D is equals to D0 1 minus V square by C square, which is equals to 240 into 60 into 3 into 10 to the power 8 root over 1 minus 0.99 square. So this value would turn out to be 240 into 3 into 10 to the power 8 into 0.141 meter. Thus, the time measured by the observer in the spaceship is T is equals to D by V, that is 240 into 60 Here there is one term of 60 which I missed it, so I would be writing it again into 60 meter. So 60 into 3 into 10 to the power 8 into 141 meter divided by 0.992 3 into 10 to the power 8. And this value will turning out to be 34.18 into 60 seconds. That is, let us check the approximate 34 minutes. So our answer is option A. Cobalt is a radioactive nucleus of half-life tool Ln2 into 10 to the power 10 second. The activity of 10 gram of cobalt in disintegration per second is. So we have to determine the activity. Solution. We have T1 by 2 equals to 2 Ln2 into 10 to the power 8 second. M is equals to 10 gram. Molar mass is 58.93 Na, where Na is Avogadro number and Na is equals to 6.023 to 10 to the power 23 atom per mole. ठीक है. Now, half-life is given by T equals to 1 by 2 ln 2 by lambda. So imply lambda would be ln 2 divided by T 1 by 2, which is equals to ln 2 ln 2 into 10 to the power 8 ठीक है per second, which is turning out to be 5 into 10 की power minus 9 second inverse. The radioactivity of the atom is defined as R is equals to n lambda, which is turning out to be m by capital M into Na lambda. Oh sorry, this is not, Na is separately. Here 53 Na. Now this turning out to be 10 divided by 58.93 into 6.023 into 10 की power 23 into 5 into 10 की power minus 9 is equals to, that value would turn out to be 5.1 into 10 की power 14 disintegration per second. Per second. So our answer for this question would be option D. That is 5 into 10 की power 14 disintegration per second. Let us read the statement for this problem. A particle of mass m is confined in a potential box of side Ls, Ly, Lz as shown in the figure. By solving the Schrödinger equation of the particle, find its eigenfunction and energy eigenvalue. This is a cuboid box, and for this we have to solve the Schrödinger equation and determine its energy value and eigenfunction. Now, solution. The Hamiltonian for a particle mass m moving in a cuboid box is would be del square by x square plus del square by del y square plus del square by del z square plus vxyz, where vxyz would be equals to vx plus vy plus v of z and vxyz is defined as 0, 0, 0, 0 x less than a, y less than b, and 0 z less than c. The above Hamiltonian is written separately in x, y and z variables. That is h equals to hx plus hy plus hz, where hx is defined as minus h square by twice m d square by del x square plus v of x. Hy is defined as minus h square by 2m del square by y square plus v of y. plus hz is defined as minus h square by 2m del square by del z square plus v of z. Using the method of separation of variable, psi x y z is defined as phi of x, phi of y, phi of z. Now substituting the value of psi x y z in Schrödinger equation and divide the whole equation by psi x y z, we get h psi equals x y z equals to e psi x y z, which can be written as, and now whole equation is divided by x y z, and here's psi x y z, or e would be equals to h of x phi of x by phi of x plus h of y phi of y by phi of y plus h of z phi of z by phi of z. Further, this is equals to e n x plus e n y plus e n z, as we know that h x phi n x equals to e n x phi n x, where phi n x is equals to root 2 by a sine nx by x by a, and e nx is equals to nx square pi square h square by 2ma square. Similarly, hy phi ny would be eny phi ny of y, where phi ny of y would be root 2 by b sine ny pi y by b into eny equals to ny square pi square h cross square by 2mb square. hz phi n z would be enz phi n to z would be phi n z of z would be root 2 by c sine n z pi of z by c, and into e and z would be nz square pi square h square by 2mc square. Thus, substituting the values of Enx, Ny and Enz in the expression of E, we get E is Nx, Ny and Z equals to Enx, Ny plus E and Z equals to Nx square by A square plus Ny square by B square plus square by C square into I square H square by 2m. The function psi x y z is given by psi x y z is equals to phi of x, phi of y, phi of z, that is 8 by ABC, sin nx pi x by A, sin ny pi y by B, sin nz pi z by C. So energy would be this. The function is given by this. These questions come in a 21 marks, completely derivation, nothing else. With this, we end our problems of IIT-JAM 2012 of modern physics.